A very good morning. We are excited to share our project on facial skin texture analysis with you today. I'm Tivian, joined by my talented teammate Tachaini and Kashwini. In this slide, we will cover several key points. First, we will discuss proper background, explain the importance of analysis facial skin texture. Next, we'll dive into methodology, detailing the technique and pre-process and process we use for analysis. Then we walk through the program code that underpin our system. Then we will show you the output illustrating the result of our analysis. Finally, we wrap up with our conclusion, summarizing our finding and the implication, followed by our reference. Our project involves creating an automated system to analyze facial skin image with a focus on identifying and differentiate between oil and dry skin area. We utilize the advanced image processing technique to enhance, smooth, and segment the skin area. These techniques allow us to provide detailed insight into skin characteristics. By implementing this system, we aim to deliver precise skin analysis that can support dermatologists' study, improve skincare recommendation, and educate customers about their skin types. Now, let's move on to objective of our project. Our primary goal is to develop a system that can accurately identify and differentiate between oil and dry skin area in facial image. This will provide precise insight into skin type essential for various applications. We are also aiming to create a system capable of real-time skin analysis. This feature will provide immediate feedback, making it a valuable tool for both professionals and consumers. By enhancing the understanding of skin characteristics throughout precise and detailed analysis, we aim to support dermatologists in their research and diagnosis. This will aid in developing better treatment plan and improving patient care. Finally, we want to help consumer understanding their skin type and condition. Empowering them with this knowledge will enable them to make informed decisions about their skincare routine and product choice.
On the methodology part, let me explain about the project. First, begin the process. Next, load the image, and then we convert the image to grayscale. So, the loaded color image is converted to a grayscale image, simplifying the subsequent processing steps by reducing it to one channel. So next, we apply histogram equalization for image enhancement, and then we apply Gaussian filter for image smoothing, and then we convert image to binary using thresholding, and then we apply morphological operations to remove noise and fill holes, and then we segment the oily and dry skin areas using k-means clustering, and then we visualize the results. Then we calculate the percentage of the image area covered by oily skin and dry skin, and then we printed out the results. Thank you.
Now, I'll be presenting first part of the program code. Here, our goal is to enhance and pre-process an image for further analysis. Let's work to the steps involved. The first step in our process is loading the image. In this case, we are working with the image named Oily JPG. We use ImRead function to load the image into MATLAB. Next, we convert the image to grayscale. This simplifies the image and reduces computational complexity since we only need to work with intensity value. We use RGB to gray function for this conversion. To enhance the image, we apply histogram equalization using the histag function. This technique improves the contrast of the image by spreading out the intensity values, making feature more distinct. After enhancing the image, we apply Gaussian filter to smooth it. Smoothing helps it to reduce noise and fine details, which can be beneficial for subsequent image processing step. We use the imgauss function with a sigma value of 5. Finally, we convert the smoothed image to binary image using thresholding. Thresholding differentiates between the foreground and the background based on the intensity value. We use gray trash to determine an optimal threshold value and I binarize to perform the conversion.
I will be presenting the second part of the code. So here the morphology operations are applied to the binary image to remove noise and fill holes. This involves creating a circular structuring element with a radius of 5 pixels and using it to perform morphological closing, which helps in connecting disjointed parts of object and eliminating small holes. After this, the infill function is used to fill any remaining holes in the binary image. Once the noise is reduced and holes are filled, the image is segmented into oily and dry skin areas using k-mean clustering. The binary image pixels are converted into a one-dimensional array and clustered into two groups. The resulting clustering are then reshaped back to the original image dimension, and pixels are classified into oily or dry skin area based on their clustered label.
Here I have built the images in 2 times 2 grid. The first one is the original image, secondly the enhanced image, followed by the segmented oily skin areas and then segmented dry skin areas. Next, calculate the percentage of the image area covered by the oily skin and dry skin by summing the respective pixel counts and dividing by the total number of pixels. And then the results will be printed out.
In this part of the code calculates and display the percentage of oily and dry skin areas using a bar graph. The area are computed as the proportion of pixels belonging to each cluster and are converted to percentages for visualization. Additionally, histograms of the grayscale image before and after histogram equalization are plotted to illustrate the enhancement effects. The original histogram shows the distribution of pixel intensity value in a unprocessed grayscale image, while the enhanced histogram displays the spread out of and more uniform distribution of intensities after histogram equalization, indicating an improved contrast in the enhanced image. This visualization helps in understanding the effectiveness of the image processing techniques. Thank you. Now let's look on the output of our program. So we will get three figures from our program. In the first figure, we will have a 2 times 2 grid in which the top left consists the original image of a face before any processing. And then on the top right, it is the enhanced image where the original image is converted to grayscale. Histogram equalization is applied to enhance the image, making features more distinct by spreading out the most frequent intensity values. On the bottom left is the oily skin area where it will identify by clustering similar intensity value after noise reduction and thresholding. The oily skin appear distinct in the enhanced image. The binary image highlighting areas, which we can see the black shaded region, is identified as oily skin, whereas on the bottom right is the dry skin area. It is similarly identified by clustering. Dry skin are the area that are complement of area in the binary segmentation. In the comment window, we can get the calculated percentages, which shows the segmentation result, providing a numerical summary of the skin condition by indicating the proportion of the image covered by oily and dry skin areas. And it will be visualized with a bar graph of the proportion of the oily and dry skin area, making it easier to compare the relative coverage of each type of skin condition. In the third or last figure, the histogram will illustrate the effects of histogram equalization by showing the distribution shift from the original to the enhanced image. They depict how pixel intensities are spread across the grayscale range. The histogram of the original grayscale image shows the concentration of value in mid-range, while the histogram of the enhanced image shows a more uniform distribution, indicating improved contrast. Welcome to the demo of our mini project facial skin texture analysis program. So for this we need to get ready with our code. So here is our code, and then we are using image 1 as our input. So now let's run the code. When we run the code, we will first get the percentage of oily skin areas and dry skin areas in the command window, followed by three figures. In the first figure, we will have the 2 times 2 grid of original image, enhanced image, and oily skin areas, dry skin areas. The part, the black color shaded region, is the oily skin area, while here the black color region is the dry skin area. And then when we look at the graph, so this is the bar graph visualization of the percentage that was shown here. As you can see here, here the skin is more dry compared to oily skin. And then we have the histogram of both original grayscale image and enhanced image. So as we can see, the mid area is more intense. So after the enhancement, the histogram equalization, it has been distributed evenly. So that's all for the demo. Thank you.
Moving on to the conclusion, what we have learned. The first one is image processing techniques. We have learned various image processing techniques, including image loading, conversion to grayscale, histogram equalization, Gaussian filtering, and binary thresholding. These techniques are essential for enhancing image quality and simplifying the analysis. The second one is morphological operations. Our project demonstrated the importance of morphological operations such as closing and hole filling to remove noise and ensure the continuity of segmented regions. Next one is segmentation with K-means clustering. We explored the use of K-means clustering for segmenting different skin textures, particularly oily and dry skin areas, providing a clear method to categorize and analyze screen regions. On the advantage side, the first one is improved accuracy. The use of advanced image processing techniques and the clustering algorithm, it improves the accuracy of skin texture analysis. The next one is automated analysis. It provides an automated method to analyze and segment the skin textures, reducing the need for manual inspection. On the other hand, sensitivity to image quality. The effectiveness of the analysis can be highly dependent on the quality of the input images. Poor quality images may lead to inaccurate results. The next one is threshold dependency. Binary thresholding can sometimes be sensitive to lighting condition and may not yield to the best segmentation results. So what are the constraints we face on this project? The first one is image quality. High quality images were required to ensure accurate analysis. Low resolution or purely lit images could affect the accuracy of the results. And then parameter tuning. The need for careful tuning of parameters such as the threshold for binary conversion and the standard deviation for the Gaussian filter added more complexity to the project. Next one is algorithm limitation. The choice of algorithms, K-means clustering, it is impose certain limitation on the segmentation as they may not perfectly capture the variability in skin textures. That's all for us. Thank you.